All right, hello everybody. Let's do this. Question number 3. So, the radius of a sphere. So, what do we mean by a sphere? You have to think of, like a ball or a basketball, a volleyball. What does a sphere look like? This is my best. It's a three-dimensional shape, right? That is our sphere. So it's saying that the radius of the sphere. So if you have some sort of three-dimensional, think of a basketball, there is a radius within the center of that basketball or sphere. And let me actually zoom in on this. So imagine this is your basketball, and there's a circle, and here's another circle. Within that, the center of a sphere, there's a radius, and imagine it being the center of the ball, and it could go to any exterior part or the outside part of the sphere, and that's just the radius of the sphere. So notice here in this problem, it's saying that the radius of your sphere is increasing at a constant rate of 3 centimeters per minute. So what's happening to the ball or to the sphere? If it's increasing at if the radius is increasing, then the sphere is just going to get bigger and bigger and bigger. So notice that the sphere is like this, and then maybe a second later it gets something like this, and then it gets even bigger in the next one, right? So let's continue reading. It's saying at the instant when the radius of the sphere is 4 centimeters, what is the rate of change of the volume? So volume, we have to be okay with this word. Like before, if I have a circle and I said, what's the area of the circle? It's how much is on the inside. But with volume talks about a three-dimensional shape. So if I had, for example, okay, so let me get something for you guys real quick. Here. All right, so this is Mr. G. Let's say if I have, okay, this is not working out. Let's say if I have a glass, right? How much water can I put within the glass? That's volume. It's how much you could put on the inside. Okay. All right. So now here, the next part is saying, what is the volume of I'm saying the volume of a sphere can be found with the equation V equals 4/3 pi r cubed. And now it says, what do we want to find? The rate of change of the volume. It's saying, how is the volume changing within each second? Okay, so what do you know? Let's go to the first part. What do you know for sure that the volume, how do you find the volume of a sphere? What you do is you take 4/3 pi, and whatever the radius is, you're going to cube it. And this is the formula. Okay, this is just a cold formula. This is the formula for the volume of a sphere. Now, what are you given? Here, the first sentence says, the radius of a sphere is increasing at a constant rate of 3 centimeters per minute. What I'd like you to do is try and translate this sentence into a given fact. All right. So the radius of the sphere, so I have r, it's changing over time, so dr dt is equal to a positive 3 centimeters. This should be 3 centimeters per minute. Okay, every minute the sphere is increasing by 3. The radius of the sphere is increasing by 3 centimeters. Okay, let's look at the next one. It's saying at the instant when the radius of the sphere is 4 centimeters. So it's saying at an instant point your radius is 4 centimeters. Okay. What is the rate of change of the volume? So here, that's the question we need to ask. What is the rate of change of the volume? So now here, this becomes, the question is, how do you translate the yellow? dv dt equals question mark. So this is what we need to solve. All right. So what do we do? Notice that, what do you think the first move would be? Well, let's say if you got to this part, right, you say v equals 4/3 pi r cubed. What do you believe the next move would be? Okay, and by now we should trust ourselves. We're going to take d dt on both sides. Okay, now this gets a little tricky because the left side is pretty straightforward, right? How do you take the derivative of the left side? Here, this is just dv dt. Okay, no questions asked. But then how do you take the derivative of this? Notice that this 4/3, let me use a different color. This 4/3 pi, this is a constant. So you're really just taking the derivative of r cubed with respect to t, and then you're going to multiply it by 4/3 pi. So just bear with me. Notice, what's the derivative of r cubed? This should be 3r squared dr dt. Okay? But now we need to multiply whatever this is by 4 pi over 3. Because, 4/3 times pi is 4 pi over 3. So notice, how does this simplify? Notice that the 3's cancel. So now you have dv dt is equal to 4 pi r squared dr dt. Okay? Not too bad. That was not too bad. Okay? So then how do we actually continue? So now, let's see how clever we are. Do we know dv dt? We don't know what dv dt is. Do we know what pi is? Yes. Do we know what r is? Yes. Do we know what dr dt is? Yes. So you got very lucky that this problem wasn't as bad, but all we have to do is just plug in the numbers. So now you have, let's put it over here. So dv dt is equal to 4 times pi times, what does this become? R squared. R squared is going to be 4 squared times 3. The centimeters per minute, we'll get to that afterwards. But then this just becomes dv dt equals, okay, this is not bad. This is what? 4 pi times 16 times 3. But that's the same as 12 pi, because I'm just doing the 4 pi times the 3 times 16. What's 12 times 16? Oh crap. What is 12 times 16? I didn't have my coffee today. All right. 12 times 16. I bet you some of you are doing it in your head, but this is 192 pi. So that is dv dt. And notice that the question is saying round your answer to 3 decimal places. So let's actually do 192, and you could do this in your calculator, times pi, and you get dv dt is equal to 603.1857895. But now, what do we need to do? We need to round it to 3 significant digits. So we have 603.18. And notice that you see how here we have a 5/7, so this becomes a 6. And now, how do we have the correct units of measurement? Because we're talking about volume, we're going to have centimeter cubed per minute. Okay? And that's it. It's saying that, what does this solution mean in the context of the problem? It's saying every second the radius is increasing by 3 centimeters. So how is the volume changing? It's saying every second the volume is increasing by 603.186 cubic centimeters per minute, that it's growing. That how much more can you put inside? It's growing by this much. Okay? Now, try and do question number 4 on your own. Very, very similar. Okay, try and do this one on your own before you watch the next video. I believe in you. Enjoy.